Students, hope you are doing well. Today we are going to do the coupled analysis structural plus thermal in LISA software. So the question is given: determine the nodal displacement at node 2 and stresses in each material and support reaction in the bar shown in figure due to applied force P 400 kilonewton at node 2. So temperature rise is 30 degrees Celsius. Okay, you can see this is the diagram is given. So this is first material made up of aluminum and second is steel, and P is the 400 kilonewton applied force. Now all the Poisson's ratio is also given. Young's modulus for each material is given. Then thermal expansion coefficient is given. So on the basis of area, if we calculate the diameter, so we will get the aluminum diameter is 55.27 and the steel diameter is 39.08. Okay. Now let's solve this in the LISA software. So if you see here first and second, so and third node, the third node is a fix. Okay, and at the first node there is a hinge is there. Okay, so we will going to see how we can solve this problem in the LISA software. Okay. So let's start in the LISA software coupled analysis. So first here we will going to create a nodes. Sorry, here we are going to select it. We are going to say thermal transient. Here we are going to say thermal transient. Say OK. Now create nodes. So nodes are, say, first node is 0 0 0, add. Now next node is at 300, this is second node, and next node is plus 400, that means 700. So add, close it, fit to screen. Now next is we are going to add the element, new element. So here we are going to see line to fin, say 1 comma 2, add. Then again 2 comma 3, add, and close it. Here we can edit also, we can make statistic. Here again we can edit and we are going to make the static 3D. Say OK. Now next is, now we have to apply the material. Okay, so here I will select this, select this new component. In this component assign new material. So first element is selected, so that material is circular bar having diameter 55.27. this is aluminum material, so isotropic, say here, that is 0.7 into E5. Poisson's ratio is 0.3 and the thermal expansion coefficient is 22 into 10 raised to minus 5, that means E6 minus 6. Close it. Now if you see here, so if you see here, the material is get applied. Now next is again element, select this, okay, so element, select element is this, then here new component, so this is second component, element is assign new material. So you have to assign new material, say circular bar having diameter 39.08. its mechanical property is isotropic, and this is steel material 2 into 10 raised to 5, 2E5 Poisson's ratio is 0.3 and thermal expansion coefficient is 12e minus 6. Okay, that is already given in the question. Say close it. Now you can see, so both the materials are applied, their color is also different. Now next is what we are going to do, we are going to do the applying constant. So this end is fixed, so I will select it, load and constraint, new fixed support, it is showing. Okay, so this is end is fixed. Now next is at this second node. Okay, select the face, then select new force. So what force we have given, so we have given 400 kilonewton in x direction, so 400 kilonewton. Say okay, so this force is also applied. Now what is next, this, so it is here we have the hinge support. So here load, say we have to give the new displacement. So here, so displacement in x, it should be the 0, it should be the 0. Okay, now next is, now we have to apply the temperature condition. So here load and constraint, here we are going to apply the new so okay, first we have to select the all the element. So here select the all element. Okay, next we have to apply the new thermal, sorry, new temperature. Okay, so new temperature, so in new temperature you have to apply say 40 degree. Say okay, next again, so let's solve it, solve. Now you can see this is generated, this display is generated. Now if you take the here, let me close it, x displacement, so I will make the displacement in the tables. So you can say displacement updates. So displacement at this point is 0.3. So what are the stresses update, so these are the stresses are generated. Okay, and so again we are going to suppose tensile force update. Okay, so these are the tensile forces that are generated. So I will copy these to clipboard, suppose I will paste it here. Okay, so this is the first condition. Now again I will make the changes. So what I am going to change, I will click on the load. First I will select the element, sorry, select the element. Then what I will go, click on the load. Now in this new thermal stresses, so we have to provide the reference temperature. So already in a problem they have given 30 degree rise, so what will be the reference temperature, it will be the 10. Say okay. Now let's again solve it. So you can see the solution is generated, so close it. So what is the display? You can see. So this is the x displacement. Then we will, what are the reaction forces? So these are the reaction forces, and 1 and 3. So close it. So total will be always minus 400. So let's make a take in table. So in previous table what we have taken? Displacement in x, longitudinal stresses, and the tensile force. Update it. Okay. So let's copy to clipboard. So let's check it. So you can see here, this is what? Stresses. Okay, you can check displacement is change. Displacement is change. Also tensile forces are also changes. Okay, also longitudinal stresses are also changes. Similar thing we can do. Okay, I will close it. So here instead of this temperature, I will do this at, okay, I will see, this is the 40-degree temperature we have done. Similarly we are going to do it at, say, 70 degrees Celsius. Okay, and what will be the thermal stresses? Say their difference should be, so I will say reference temperature is 40 degree. Say now we are going to see the solution. Solve. Okay, close. So you can see here. Okay, now if you want to see the simulation, you can see the simulation. Okay, because this end is fixed, and this end point is also, it only allows the movement in the y and z direction. X direction is fixed. This point node cannot be moved. Okay, now we are going to see again in the table. So in the table, previous table, we have taken the displacement, and we have taken the longitudinal stresses. Again we have taken the tensile forces. So I will say update. Okay, so now you can see here, I will copy this to clipboard. Okay, now you can see this is with the 40 degree 30-degree difference. Okay, so these are the readings. So we can get the same result if we increase the temperature with reference temperature. Okay, so now this is the stresses. So main purpose of this to understand the how the stresses behavior. Okay, in the normal condition and when there is a temperature is applied. So we have completed this. Now if you want to see the reaction forces, uh, you can see these are the reaction forces. Okay, so now this question is completed. Thank you. You can see the simulation.